What's up, YouTube? Welcome back to another Golang series. So, are you interested in building real-time chat applications? Do you want to learn how to use cutting-edge technologies like Golang and React.js to create a fast, responsive, and user-friendly chat app? If so, then you come to the right place. In this series, we'll show you how to build a Golang chat application with React.js from start to finish. By the end of the series, we'll have the skills and knowledge you need to build your own chat app. So let's get started. We're going to start by creating a server directory. Let's cd into it. We're going to start by creating a new Golang module. The convention is to use the GitHub repository that you'll be creating. So I'll be creating a chat app repository in which I'll have the server as the Golang module. Once you've done that, you'll see a new go.mod file created. You don't have to interact with it directly, but it will keep track of the Golang project that you're building. The next step would be to create a main.go file. We can now open up the main.go file and write code for our chat server. We're going to start by defining a package name. It is necessary to define what package every file in the Golang project belongs to. We can now create our main function. The execution of our project will begin from the main function. It's similar to how main function behaves in other languages like C and C++ or the main function in Rust. We now import the HTTP package. This will help us create the basic API that we require. And we call the new server mux function, which will create the router for us. We define a new endpoint. This will be the home route. And we'll use the handler func method to write a function which will handle requests coming to this endpoint. So this is what the function would look like. Inside here, we can write the logic of how we want to handle the requests. So to send back a hello world message, we use the fprintline, which is the file printline method of the built-in format library. And in here, we write to the response writer that we have within our handler function. So this should be enough to create a super basic server that has one endpoint which just returns a hello world message whenever requests are sent to it. But before we test this out, we will need to define the endpoint and the port where we want to listen for incoming requests. And the way to do that is to call the listen and serve method of the HTTP module. We define the port where we're listening to, and since we're not defining the IP address, it defaults to the home IP address. And we pass in the handler, which is the router for our server. We can now run our program by doing a go run dot, and we can test out the server that we have created by just going to Chrome and sending a request to the 3001 port. So this was pretty simple. We created one endpoint that sends back a hello world whenever a request comes in. And similarly, we can add more routes for the handler by calling the handle func again. So if we wanted to have a WS for WebSocket for our chat app, then we can define it this way. So this does get pretty cluttered pretty quickly, and we can make this cleaner by just pulling out the handler func we have provided and defining a separate function in which we will put the logic. So now that we have a say hello function, we can just add that into our handler here. Similarly, we can pull out our WebSocket endpoint as well, and we can add that to the handle function. So now we need to write out the logic that will handle WebSocket connection requests coming from the clients. And to implement this whole functionality, we are going to be using the standard WebSocket package that's provided by Golang. This is where we can find it. So we can just copy over the path to the package and we go get the path that we copied. And this will install that package to our application. So once we do that, we've now added the WebSocket package to our project. So once we go get the package, we see that there's a go.sum file that's created. And this will be used for keeping track of the exact package versions that we are using for our project. So once we have the package installed, we can now import it and use it in our project. So now that we have this set up, we can now implement the logic that handles WebSocket connections coming from the client. Now, the way we handle regular HTTP requests in Golang is that we just have the response writer and the request coming into the function. And the way we must handle it in the case of a WebSocket is that we just have a WebSocket connection coming into the handler. This is the way we would handle the incoming WebSocket connections. And we provide the handler a little differently as well. So instead of a handle function, we just have a handler.handle. Now inside here, we can start implementing how we want to handle the WebSocket connections that we're getting from our clients. Now I'm going to implement this in the most simple way possible, where we just echo back the message that we receive from the client. We use the WebSocket message receive function, which will take in the WebSocket connection, and it takes a memory location where we will store the incoming message. So we define the variable where we're going to store the message, and we provide the reference to that variable. Now we get back an error from the message received in case there's an error that may have occurred. So we add a check if the error even occurred. If it did, I'm just going to print out the error for now, and I'm going to return out of the function. If the error did not occur, then now we want to echo back whatever message we received from the client, which is pretty similar to how we receive messages from the client. We just do a WebSocket message send, and we put in the message and the WebSocket connection. We receive an error here as well. I'm going to handle it in the same way as we did with receiving it. And that should be enough. Now time to test our WebSocket handler. If you try to send a regular GET request from your browser to the WebSocket endpoint, you're just going to see that the WebSocket protocol is not available because we're just sending a regular GET request, an HTTP GET request, and that's not how we're handling those requests. To test out this endpoint, you're going to have to open up your console, and we're going to create a new WebSocket connection. We're going to add a new event listener to the socket, which whenever we receive a message from the socket, we're going to print out a message from server and whatever data we receive from the socket. Now we can send a message to the socket using socket.send and the string value that we want to send to the server. So we see that we received a message back from the server, message from server, hello world. We can also add a print statement to the server. Now, if we try to send the message, we see the printed message in our terminal. But if you try to send another message to the server, you're going to see that we don't see the print statement. We also see that the WebSocket connection is closed on the client's end. Now, this is happening because we're receiving a message from the client, we're sending it back, and we're getting out of the function, which means that we are terminating the WebSocket connection. This means that our connection no longer exists on the client's end. And now, no matter how many messages the client sends, they're not received on the server's end. To resolve this, we're going to implement an infinite loop in our WebSocket handler. This is so that the WebSocket connection stays persistent even after we have sent back the message to the client. And the infinite loop is only exited if an error occurs while receiving the message. Now, as we try to reestablish the connection and send the message, we see that we receive the message back from the server. If we send it again, we see that we're getting back the message. And we can try this as many times as we want, and we see the same thing reflected on the server end as well. So now we have a two-way communication happening between the server and the client. The client sending messages to the WebSocket handler. The WebSocket handler is now echoing back all the messages that are received by it from the client. And the way to close the WebSocket connection from the client's end is to just do a socket.close. And now we have closed our communication. If we try to send back another message, we see that the WebSocket is already closed and we don't receive that message from the client. Instead, we see an end of file error on the server end when nothing can be read anymore from the WebSocket. So now that we have that basic understanding of WebSockets, in the next video, we're going to create a chat room architecture using our WebSocket setup. We will keep track of all the users that we're receiving requests from. And every time we receive a new message from either of these users, we're going to broadcast it to all the users that we have kept track of. So stay tuned for that video. Until next time, thanks for watching.